Okay, so today I want to start off by going over a few more things about gases. So, if you remember from the screencast you watched before today's class, I mentioned that with gases, as you increase the temperature, unlike solids, gases become less soluble. Another difference between solids and gases in solution is that pressure can also affect the solubility of gases in solution. Pressure will not affect the solubility of solids or liquids in solutions, but will affect the solubility of gases. Okay, so when we look at a solution, if we increase the pressure above the solution, this allows more gas to dissolve in solution. So, like I said, the solubility of liquids and solids does not change very much with pressure, but the solubility of gases in a liquid is directly proportional to the pressure above the solution. So, when you buy soda, one thing you'll notice is that when you open up a bottle of soda, you'll hear this whoosh sound as you open up the bottle, and that's because when they bottled the soda, they actually put some gas right above the solution, a high pressure gas right above the solution to keep that carbon dioxide dissolved in your bottle of soda. Okay, so Henry's law describes this relationship between the solubility of a gas and the pressure. So, solubility, S1 is the solubility of a gas at one pressure, and S2 obviously is solubility at different pressure. So, you look at the picture here, you have a gas at low pressure, you have very few gas molecules in the atmosphere above that solution. So there's really nothing pushing, there's not too much pushing against that solution, so it's pretty easy for the gas molecules to escape. If you have higher pressure, you have a lot more gas molecules in the atmosphere above the solution bouncing against that surface of the solution. It makes it much more difficult for the gas molecules in the solution to escape from the solution, say stay in the solution for a longer time. Okay, so I want to look at some problems using Henry's law, and you will have a Henry's Law worksheet for homework. Here's a Henry's Law worksheet. This is under classwork. For those of you that are online, those of you in class should have a copy of this. And what we have here in a problem like this is you will have the solubility, and sometimes it will be grams per liter, sometimes it will be moles per liter. It will vary depending on the problem. And you will also have a pressure. Sometimes it'll be atmosphere, sometimes it'll be kPa. It'll vary according to the problem. In each case, you need to make sure your pressure units and your solubility units are the same. So if they're not, you're going to have to get them into the same unit. Sometimes also they will include the temperature, and the temperature is just extra information, so you kind of ignore that. So here they're telling us that blood contains about 0.25 grams of oxygen per liter. So S1 is 0.25 grams per liter. And it's telling us the pressure is standard atmospheric pressure. So P1 is 1 atm. So remember that's 1 atm or 760 millimeters of mercury. So here they're saying, what is the solubility of oxygen in blood if you climb Mount Everest, and the pressure now is 0.35 atmospheres. So P2 is 0.35 atmospheres. And they're asking us, what is S2? So again, your formula is S1 over P1 is equal to S2 over P2. You substitute this information into the equation, making sure that your units are matching up, and they do. It does not ask for a particular unit for solubility, so you can leave it in grams per liter. So you plug in 0.25 grams per liter over 1 atm is equal to S2, that's our unknown, over 0.35 atm. We notice here the atmospheres cancel out, and then we can solve for S2. So we see S2 is when we cross multiply is going to be 0.25 times 0.35. And that's going to give us S2 is 0.8, excuse me, 0.0875 grams per liter. And here, if you were to think about sig figs, since you have just one atmosphere, you could say that S2 is 0.09 grams per liter. Okay, so that's a typical problem on this sheet. So again, you just have to read the problem very carefully. When you get to the end of the sheet, I just want to show you a couple things here at the end. When it's asking you what makes carbon dioxide more soluble in water than oxygen, and what is more soluble, nitrogen or oxygen, what you have to do is you have to think back to your notes from from the screencast for today's class. And if you go back, you will remember that we talked about how mass affects the gases in solution. And also, if you were to have polar and nonpolar, you would have to think about water and if something's polar or nonpolar to figure out which would be more soluble. So that kind of information is going to help you with those questions.